Mathematics is a universe of numbers and equations. It governs the laws of nature and helps us understand the cosmos. But within this universe, there are mysteries. Some mathematical expressions seem to defy logic. These are called indeterminate forms. They pop up in calculus, challenging our intuition. Let's dive into this intriguing world. Imagine dividing 0 by 0. What could it be? 1, 0, or something else entirely? These forms, like 0 divided by 0, infinity divided by infinity, or infinity minus infinity, don't have a single defined answer. They are indeterminate. The study of indeterminate forms is crucial in calculus. They appear when we explore limits, a fundamental concept about approaching values. Understanding these forms allows mathematicians, scientists, and engineers to unravel complex problems and make groundbreaking discoveries. Let's start with the simple question. What is 0 divided by 0? Seems straightforward, right? But here's where things get tricky. Any number multiplied by 0 equals 0. This simple fact throws a wrench into our usual understanding of division. Consider this. 10 divided by 2 equals 5, because 2 times 5 equals 10, but with 0 divided by 0, any number multiplied by 0 in the denominator could potentially work. It could be 1, 100, or even a million. This ambiguity makes 0 divided by 0 indeterminate. It has no single defined value. This indeterminate nature doesn't mean we're stuck. Calculus provides us with powerful tools like L'Hopital's rule. This rule helps us find the limits of functions that initially appear as indeterminate forms. The concept of infinity adds another layer of complexity to indeterminate forms. Imagine Hilbert's Grand Hotel. It has an infinite number of rooms. Now imagine every room is full. A new guest arrives wanting a room. Can you accommodate them? Surprisingly, you can. Shift the guest in room 1 to room 2, the guest in room 2 to room 3, and so on. This leaves room 1 vacant for the new guest. This thought experiment illustrates that infinity plus 1 is still infinity. Now imagine an infinite number of guests leave the hotel. You still have an infinite number of guests remaining. This shows that infinity minus infinity can result in different values, making it indeterminate. Section 4. Indeterminate forms in calculus. Limits and L'Hopital's rule. Indeterminate forms are not just mathematical curiosities. They are essential in calculus, especially when dealing with limits. A limit describes how a function behaves as its input approaches a certain value. Sometimes, when we try to directly substitute the value into the function, we encounter an indeterminate form. Take the function f of x equals x squared minus 1 over x minus 1. If we substitute x equals 1, we get 0 over 0, an indeterminate form. However, using algebraic manipulation, we can simplify the function to f of x equals x plus 1 for x not equal to 1. Now, the limit as x approaches 1 is clearly 2. L'Hopital's rule is a powerful tool for tackling indeterminate forms in limits. It states that if the limit of the ratio of two functions results in an indeterminate form, we can find the limit by taking the derivative of the numerator and denominator separately and then evaluating the limit again. Section 5. Real-world applications from engineering to physics. The study of indeterminate forms is not limited to theoretical mathematics. It has profound implications in various fields, from engineering to physics. Engineers use calculus and indeterminate forms to analyze the behavior of structures, optimize designs, and ensure safety. In physics, indeterminate forms appear in calculations involving motion, forces, and energy. For example, calculating the instantaneous velocity of an object at a specific point in time often involves dealing with the indeterminate form 0 over 0. Understanding indeterminate forms allows scientists to model complex phenomena, such as the behavior of black holes or the expansion of the universe, where traditional mathematical approaches might break down. Section 6. The enduring significance of indeterminate forms. Indeterminate forms, once perceived as mathematical dead ends, have evolved into fascinating areas of exploration. They challenge our intuition and force us to delve deeper into the intricacies of mathematics. Their significance extends far beyond theoretical calculations. They are essential tools for scientists, engineers, and anyone seeking to understand the complexities of the natural world. As we continue to push the boundaries of knowledge, our understanding of indeterminate forms will undoubtedly play a crucial role in shaping the future of science and technology.